morning, friends. So today we are starting with the discussion of atomic structure. So before we go into the discussion of some of the numericals and questions with respect to atomic structure regarding NEET and KCT, so let me just revise certain important aspects of this atomic structure which we can use later for our calculation purposes itself. So the first thing is, when we talk about the electrons to be filled in various shells, all of you have the basic ideas how exactly do we fill the electrons in various shells. So there are certain rules on the basis of which we are arranging electrons in various shells. We have Bohr's principle, we have Pauli's principle, we have de Broglie's equation with respect to wavelength and momentum interaction of the electron, and many more equations respectively, on the basis of which we are filling electrons in various shells. So according to Bohr method, we arrange electrons in terms of the increasing energy of shells. That is, we need to fill the shells first which have got less energy, because if energy of any shell is less, then its stability is more. So that is natural. So electron would like to be in a shell which has got more stability. So more stability complies to less energy. And a general rule with respect to stability in terms of Bohr method is, we need to arrange electrons on the basis of, first of all, n value, and if n value is same, we'll go with the second part of Bohr method called as n plus L rule, because every one of you knows these basic fundamentals clearly. That's why I'm just revising these things very fast. So on the basis of n value and n plus L value, first of all, if n is less, then energy of an atom is also less. Let us understand that how does it exactly come into play. So when you look on an atom and you look on various shells where electrons are actually present, if electron is more close to nucleus, it is under a greater pull of the nucleus. As a result of that, the stability exercised by this electron close to nucleus will be more. So naturally, electrons are filled in the shells with less n first. What if n value of the two shells is same? N is principal quantum number. So when we look on the n value, suppose we talk about 2s and we talk about 2p. So n value is same, we'll fill the electrons in which n plus L is less. So we are making use of one more quantum number, that's azimuthal quantum number here. So n plus L should be less. Suppose for 2s it is n plus L, for 2s will be equal to, what is n value here? 2 plus, what's L value? 0. So 2 plus 0 will be 2, and for 2p naturally it will be 3. So electron will be filled in 2. These are fundamental things, you know very well about all these things clearly. So these are two important things that you need to understand in this discussion that I am going to start with, which is the concept of spin multiplicity. This needs to be understood very carefully and clearly, the concept of spin multiplicity. Now, when you look on certain statements like Pauli's principle or Hund's rule, we have the statement of Hund's rule. What does it state? That pairing does not take place unless all the available orbitals are singly packed. One important misconception regarding this concept is that when we define it, we say pairing will not take place unless all the electrons are singly occupied, but the condition is all degenerate orbitals. So what exactly does a degenerate orbital mean? Degenerate orbitals are the orbitals with same value of n, so n is same as well as L is same. So technically these degenerate orbitals are belonging to same subshell. Say we got 2p. We know we have got 3 orbitals of 2p, which is 2px, which is 2py, which is 2pz. So naturally, n value is 2 here. This is n value, px. Actually, these are the 3 orbitals of p. So we have n value 2. This will be L value. So in 2px, 2py and 2pz, n plus L is equal to 2 plus 1. That is technically 3. So when n plus L is same, n is same, L is same, only then the orbitals are called as degenerate orbitals. If n plus L is same, it doesn't mean orbitals are degenerate. Let's have a look, a basic thing. Suppose 2s and 2p, or 3s and 2p. Let's have a look on 3s. What is n value? 3. What's L value? 0. And here what's n value? 2. What's L value? 1. So total n plus L 3. Here also 3. So you got n plus L for both cases how much? 3 each. But still they are not degenerate. So if you have to fill electrons in 3s and 2p, so you need to make a use difference of what? N value rather than n plus L. Because the first fundamental rule is which one? Bohr principle. Followed by Hund's rule. When we elaborate it out, we say Hund's rule of maximum multiplicity. So we'll take one basic case into consideration. Let us see here, we talk about nitrogen. We'll talk about nitrogen atom here. Atomic number is 7. So when we write electronic configuration, how do you write it? 1s2, 2s2, 2px1, 2py1 and 2pz1. This we are making use of which rule? Hund's rule. Now what is the word that we are using for it? Hund's rule of maximum multiplicity. What exactly does it mean? Now if you fill electrons in this like 2px2, 2py1 and 2pz0, this is not allowed according to Hund's rule because you have still z orbital free. So you have not made use of all the spaces that are available to you. So you got px, you got py, you got pz. So you have not made use of z axis. You have compressed px more and py is also occupied. The best way is to give electrons in each of the 3 orbitals so that all the 3 orbitals in a space will be occupied, which will lead to decreased energy, leading to more stability of the complex. So we'll have 2px1 according to Hund's rule, 2py1 and 2pz1 configuration. Now because of this, there are 3 unpaired electrons, and there is a very important concept of spin multiplicity wherein we have stability of a shell due to exchange energy and due to symmetric arrangement of electrons. Exactly how? So exchange energy. So there are 3 electrons in X. So it will be px1, py1 and pz1. Compared to that, if I take px2, y1 and z0. So there is no exchange possible here because electrons are not here. So you got only 1 electron. Exchange is possible between unpaired electrons. So how many exchanges are possible? So you can have shift off here. So you can have shift off 1 to 2, then 1 to 3, then you can shift off 2 to 3. So how many shifts are possible? 3. Due to 3 exchanges, some of the energy, the amount of energy lost out during the exchange, we call that as exchange energy. So more the number of unpaired electrons, more will be exchange energy, and there is symmetric filling of orbitals. Due to these 2, the electrons do not get paired up, provided all the 3 are of same energy. If they are not of same energy, then you cannot make use of spin multiplicity rule at all. One more important concept with respect to this is, what are the different ways in which these 3 electrons can remain aligned with respect to each other? We call that as spin multiplicity, the tendency of the spin of an electron, which is clockwise and anti-clockwise, to remain with respect to each other. When you look on 3 electrons, the total spin multiplicity will be 4. I'll just exactly tell you how do we get these values out. Let us just talk about this further. in a bit deeper detail because this is important. You can expect some questions with respect to these. Now let's have a look on nitrogen. What did I say, children? Exactly what did I say a while earlier? So there are how many unpaired electrons? 3. So you got electrons in 3 orbitals of p, which is px1, py1 and pz1. And what did I say? The total spin multiplicity is how much? I said 4. How exactly we can get it? You can get the total spin multiplicity of this by the formula. So spin multiplicity will be equal to what? It's equal to 2s plus 1, where s is equal to n into 1 by 2 and n indicates number of unpaired electrons. So total spin will be n number of unpaired electrons in 1 by 2 because spin is 1 by 2. So number of unpaired electrons in case of nitrogen. So when we look on nitrogen, what is n value here? 3. Correct or not? So what will be spin multiplicity? Spin multiplicity, I'll write that as Sm now, will be equal to 2 into S. What is S equal? N into 1 by 2. So what is N value? 3. So 3 into 1 by 2. That makes the whole value equal to 2 S plus 1. That makes the total value equal to what? 4. How it is so? Have a look. So these 3 electrons can remain in 4 spin states. What are they? Clockwise, clockwise, clockwise. So this is 1, clock, clock, anti. This is 2nd, clock, anti, anti. This is 3rd, anti, anti, anti. This is 4th. So there are how many spin states here? So according to this, can you tell me what about this question? Calculate the spin multiplicity of magnesium. So children, if you can do it, what will be spin multiplicity of magnesium? Let's have a look. So magnesium spin multiplicity will be calculated for which electrons? Outermost or inner electrons? Outermost, because outermost electrons only will be valent or unpaired. So magnesium's outermost electronic configuration is 3s2. So what is n value here? N value, number of unpaired electrons, 0. So what will be spin multiplicity equal to? Only 1. Because we apply 2 s plus 1. What is s equal to? 0. So that whole makes it what? 0 plus 1. So what is spin multiplicity? 1. What does it mean? It means the 2 electrons which are present in an orbital will have clockwise, anti-clockwise spin. There is no other possibility. Now for sodium, we can have how many spin multiplicities? 2. Why? Because what's the valence electrons of sodium here? Sodium is 3s1, correct or not? So what is n value? 1. Number of unpaired electrons is 1. So spin multiplicity will be 2 into 1 into 1 by 2 plus 1, right? That will be how much? 2. That will be 2, correct? What is that? The electron can remain either clockwise or anti-clockwise. These are the 2 spin states that we got for sodium. So this is spin multiplicity that comes from Hund's rule. So the statement is Hund's rule of maximum multiplicity, and you understood why we need to have unpaired electron. There are many other reasons as well. So exchange energy is one of the concepts, and one more concept of working is the concept of symmetry, because all the space in an electron has been used up properly. Now, so children, besides this important part of the concept of working, we have the concept of Bohr model, wherein we discuss about the energy calculations of various shells, whose basic formulas I will repeat. What are they? So energy of nth shell of hydrogen atom is given by minus 13.6 into Z square by n square electron volts. And if you want to find out the energy difference, delta E, it is equal to E2 minus E1, where E2 is the higher energy shell, that is E2, and E1 will be obviously what? Lower energy shell. A very general formulation which we can prove mathematically as well, I am going to give you here. What is that? If we look on an atom, let's suppose we have a look on an atom here. So children, if you look on an atom here, we got various shells. I will generalize an idea here. So if you see here, electron is present in first shell and I want to shift the electron to the second shell. What do I need?
Energy.
Correct. How much energy will be required in shifting electron from energy level 1 to energy level 2 according to Bohr's model will be equal to energy difference between the two, which will be equal to E2 minus E1. Correct or not? Now, shifting electron from E1 to E2, we need some energy, and naturally that energy will be given by some source outside. And if you use some radiation, if you use some energy to shift the electron from ground state to excited state, here I am talking about E1 to E2, we will need some energy, and the energy will be given by the photons if you are using the light source, right? So what is the energy of each photon? H nu will be equal to E2 minus E1. Keep it in mind, all the sources of energy are not sufficient enough to shift the electrons between two shells. And one more important thing, whenever you are shifting electron from one shell to other, it should always be so that once electron shifts, angular momentum should be equal to integral multiple of h by 2 pi, and where n indicates different types of shells, different number of shells that we have in an atom. Now we can prove this statement as well, and many times we have proved it out during our classes as well. So MVR equals to Nh by 2 pi. You can use the concept of circumference. I will just give a recap of that. So if you want any atom and any electron to be rotating around the nucleus, it must create integral number of waves. Say, what is this? We can take the circle. So here, what's the circumference of the circle equal to 2 pi r? So this lambda means the waves created by the electrons, n number of waves should be equal to 2 pi r. Only then electron can exist in a particular shell when integral wavelength equals to the circumference of that. Means you cannot have 1.5 waves. The number of waves that are possible should be 1 wave, 2 waves, 3 waves, 4 waves. Also, according to de Broglie's equation, we know lambda equals to h by mv. So introduce this equation here. What do you get, children? N h by mv equals to 2 pi r, right or not? So rearrange the equation. mvr equals to nh by 2 pi. This is the formulation. Clear or not? Now this is the formulation. mvr equals to nh by 2 pi. So you need some energy. H nu equals to E2 minus E1. Now my question is, if I want to shift electron from E1 to E3, do I need same energy or different energy? Correct. Do I need more energy or less energy? Now let us see that mathematically. So H nu equals to E2 minus E1. H nu dash, I will suppose, equals to E3 minus E1. If I am shifting electron from where to where? E1 to E3. So according to logic, when we are shifting electron from E1 to E2, we need less energy. From E1 to E3, we need more energy. E1 to E4, we need still more energy. From E1 to E infinity means we want to send electron out of atom. Then the amount of energy will be most, and that energy is delta E, which is E infinity minus E1, because electron has been sent out of atom. And remember, the energy of electron at infinite distance is 0. Why? Because energy of electron is due to this interaction with the nucleus. When it is out of atom, it is interaction with the nucleus is not there. So the energy is 0. Now see, when I am bringing electron from infinity into the atom, what will happen? This electron which is coming from infinity into the atom will become more stable or less stable? More stable, because pull of nucleus will be there more on it now. Once it becomes more stable, energy will be less or more. So what was the initial value? 0. Now less than 0 means negative. That's right. Minus value of energy is used for every shell. It means when the electron is out of atom, its energy is 0. And energy difference can be calculated E infinity minus E1. So we have generalized the trend. What is that? Frequency required to shift electron from 1 to 2 will be less compared to 1 to 3, compared to 1 to 4, compared to 1 to 5. So can I write the generalization here? What is that? E2 minus E1 is less than E3 minus E1 less than E4 minus E1 up till E infinity minus E1. This is a clear-cut generalization that we get from it. And mathematically we can get its results as well. 2. I'll change the scenario. What exactly now? I want to shift electron now from 1 to 2. Okay. Then from 2 to 3. Okay. Then from 3 to 4. So what will be energy difference here? E4 minus E3. Correct? Here. E3 minus E2. Correct? Here. E2 minus E1. See that in shell number 1, the only thing that is possible is excitation. Emission is not possible, because if emission occurs, it will lose energy. It follows the nucleus. That's not possible. So in shell number 1, the only thing that can happen is excitation. Correct. Now look on this. So if I want to shift electron from 1 to 2, and then I want to shift it from 2 to 3, why do I need more energy?
Because there are higher energy levels.
So where do I need more energy? From E1 to E2 or from E2 to E3?
E1 to E2.
Correct? Because when I am shifting electron from, say, I'll mention these shells here, 1 to 2 and then 2 to 3. This electron is close to nucleus or not? Pull will be more. Breaking of this electron from the nuclear force will be more or less?
More.
Correct? So is it difficult to break from 1 or is it difficult to break from 2? 1. That means energy required from 1 to 2 is more than 2 to 3.
Its energy required is more.
More from where?
1 to 2.
1 to 2 compared to 2 to 3. Why? Because 2 is far from
nucleus.
pull will be
More.
pull will be less. Once the pull is less, electron becomes lost, means electron can be lost out easily by use of less energy. So can I say logically, children, what? We can say E2 minus E1 more than E3 minus E2 more than E4 minus E3. Keep the generalization in the mind. So when the ground level remains same, the differences of energy keep on increasing. So you can have the generalization with respect to the atomic concepts into mind. And one more important generalization, all of you know. So wave number calculation equals to what? RH Z square into 1 by N1 square minus 1 by N2 square. Where RH is Rydberg's constant and its value is 109876 value. So close to that RH value. Z is atomic number. For hydrogen it is 1. So whenever you are calculating the Bohr's model for any other atom except the hydrogen, then you need to make use of value of Z. If it is hydrogen, we usually don't use Z value at all. So did you get it clear or not? Want to find out the differences clearly here? Even energy values we can do it. How? Let's have a look, children. So what did I say? Keep the generalization in mind. What did I say? I said energy difference between 2 to 1 is more than 3 to 2 is more than 4 to 3 is more than. So first postulate, E2 minus E1 is less than E3 minus E1. Let us see. So what will be delta E 2 to 1 equal to? It will be equal to E2 minus E1, correct? What is energy of hydrogen atom given by nth shell? Minus 13.6 into, what is Z value for hydrogen? 1 divided by, what is N value? Because this is second shell, it is N square, it will be 4, correct or not? Minus of minus 13.6 into 1 square by 1 square, correct or not? So what will that be equal to? It will be equal to minus 3.4 plus 13.6, so it will be almost 10.2 electron volts. This is the difference of energy from E2 to E1, correct or not? Correct. Now, what did I say? Now, what about E3 minus E1? Very simple. So, E3 minus E1 will be equal to what? Minus 13.6 divided by 9 plus 13.6, correct? So, minus 13.6 divided by 9, how much is the value? Almost 1.5, correct or not? So minus 1.5 plus 13.6, tell me the value.
14.
So 6, 5, 1, it will be 3, correct or not? 3, 1, it will be 2, this will be 1, so it will be almost 12.1 electron volts. So this is proving the statement. E2 minus E1 how much? 10.2 and E3 minus 12.1. So energy is increasing or not?
Yes, sir.
Correct? Increasing the difference or not? That's what I said. E2 minus E1 is.
Greater than E2.
E2 minus E1 is.
Greater than E2.
Now, according to this postulate, if you look on, see, we'll just do the calculation clearly. This is how divide by 3, right? Divide by 3. Yes or no?
Yes, sir.
So, in this case, E2 minus E1, minus 13.6 by 4, minus of minus 13.6. Let's make it more clearer. So, delta E will be equal to E2 minus E1. What's the statement? E2 minus E1 will be less than. Right or not? See the statements, what will be the value?
4.
Delta E will be, E2 is minus 13.6 divided by 4 plus 13.6. Correct, that is how much? 10.2. Is it coming 10.2 or not? Yes?
Yes, sir.
Next one. Delta E will be, now next one is E3 minus E2. Right? So, it is E2 minus E1. This is E3 minus E2. So, E3 minus E2 will be minus 13.6
by 9.
divided by,
9.
very good, 9. Minus minus will be plus. This will be 13.6 divided by 4. Tell me the value here. 1 point minus 1.5. Right? Plus 3.4. How much is the value?
Minus 2.
Minus. So it will be almost value of?
2.
Very good. 2.9. Exactly. Electron volts. What's the value here?
10.2.
What's the value here?
2.9.
Proved or not? Statements clear?
Yes, sir.
Clear or not?
Yes, sir.
So it is clean that when you are shifting from 1 to 2, 1 to 3, 1 to 4, 1 to 5, energy will keep on increasing. When you are going from 1 to 2, 2 to 3, 3 to 4, energy required will keep on decreasing. That means you can use less energetic photon in order to shift electron from 3 to 2 rather than from 1 to 2. Because more closer it is to the nucleus, more will be the stability of the system itself. And we know if the system is more stable, the energy required for that purpose will be more, because it needs energy to break stability. Already if a system is stable, why will it like to break? Like we say, if the electrons are pure, there is no need for breaking it at all, because already pure electrons are providing it stability. Statements are clear or not? Now, one more basic statement with respect to the moment and the position of an electron. For that we have uncertainty principle, and all of you know the statement, children. What is that? It is impossible to determine with accuracy the position and momentum at the same time. So what's the equation? Delta x into delta p equals to greater than or equal to h by 4 pi. Because p is m into v, delta x into delta v will be equal to h by 4 pi m. Because children, delta p will be delta mv. Because mass is constant, you take it out. So m delta v. So that you can use the equation delta x into delta v is equal to h by 4 pi m. Correct, children? Now, so, and as usual, now this is an important thing, one more part. So there are, everything is important atomic structure technically. So we'll look on one more aspect of this, children, because all these things have been extensively done in detail during our discussions. So we need to make sure to just recap it quickly so that it will be useful.